What's up, and welcome to Electrical Solutions YouTube channel. Today we're talking about how to tie in a manual transfer switch that will be able to use a generator with a battery backup system or grid power. The system we're going to be using for reference is a Tesla Powerwall with a Gateway 2. You can use other systems, but we're giving an example of this one because it is an AC coupled battery system, and you don't need other chargers and inverters and things like that. For the battery, you would need, depending on what type of solar system you have. So in this system, the most important thing is that we isolate whatever loads we're backing up in the selected loads panel either to the generator. So here's the selected loads panel right here, and it's either going to the generator or through the gateway. The gateway is also an automatic transfer switch, but you cannot have solar and batteries tied together with the generator. It could just be that it's grid power that you're running off of and then putting power back through the solar. But what we're specifically talking about is the manual transfer switch for the generator. Because a lot of times what I've seen happen is it'll tie it back to the grid, or your battery system isn't tied in correctly and you could be feeding your battery system. It's the most important thing is that it is isolated from any solar. So if you follow here, we're coming off the utility transformer. We're using a 200 amp main panel service. Typically you'll use a PV rated 225 amp busing and into a circuit breaker that then will feed into your gateway. The gateway is super smart. It does all types of different things through monitoring. It's a transfer switch. It can be non-backup loads. It can be the generation panel. Tesla really did a good job engineering it. So let's say that this does break. Your grid power is lost for whatever reason, whether the breaker's tripped or there's actually a grid power failure. What will happen is your batteries will kick in, and if the sun's up, your solar will also be producing, and it will stay producing because the batteries will kick in fairly quickly. It's within a couple hertz, so milliseconds, and then that will continue feeding through the selected loads panel. Let's say that battery went dead, or we didn't want to operate it off that. We would need to be able to isolate out the generation panel, because without with the batteries running and the solar running, we do not want it going to our generator. It can cause major issues. So typically what you'll use is a transfer switch that locks out one breaker and allows the other one to go through, whether it's the main or blocking out the generator, or if you switch it, it will lock out the main and allow the generator to work. So some other things to notice here, the Powerwalls, they are rated at 13.5 kilowatt hours. You can run them at 5 kilowatt continuous or up to 7 kilowatt peak. So you can run just over 20 amps at 240 all day, or you can spike a motor real quick up to just under 30 amps for the kilowatts on that. And depending on your load, how long you run it for, you can get 13.5 kilowatt hours out of that. So something else that's important here is if you're powering the or if you're using solar for the power walls, you can only put 7 kilowatts per power wall. So if you have one power wall, your solar that's tied into the load side of the transfer switch here can only be 7 kilowatts per power wall. Now, any of your busing has to be rated higher than whatever this is. Typically, you'll use the 120% rule for solar, meaning whatever size your breaker is and the PV breaker. So if this is 40, right, and this is 200 here, 120% of that would be 240, right? 200 times 1.2 equals 240. So this actually would not be to code because this is only 225 and this breaker is too big. So everything has to be, and that's just here where your main breaker is for the busing there, anywhere that the solar is tied into it. The generation panel is different because it is not getting grid power with loads in it that are running. It does have loads because the power wall will be charging, but it is not subject to that rule. So anything else would need to be rated sufficiently. So we would technically have to move this breaker down to 225 or derate this breaker down to 175 or 150 depending on your load calculation. So just to clarify, to make it work with the transfer switch, it has to be isolated away from any solar, just to feed the selected loads panel so that you don't have any issues with blowing up your inverter or potentially a generator. Alright, thanks for watching.